What is big enough? Oh, that is fine. Ah, okay, perfect.
I can screen
Okay.
the captions of your.
Very good. Very good.
Very easy. So,
Right, fine. Very good. Okay, so we're about to start this lecture. Before we really start, I want to make an announcement. Some of you may have heard there is a climate march in Princeton today, starting at the Princeton Public Library at 12:30. As you know, we professors are not advocates, we are not politicians, but this piece of information I think is relevant and is closely connected to this course. The fact that we do this course is because we are very concerned by what's going on with the environment in general and the climate in particular. So I'll be participating in this march just for full disclosure about what's going on. Okay, so now I will introduce the topic of the environment through the angle of economics in this lecture and focus on one issue, which is why, after all, shouldn't we relax and say, okay, economics will take care of it by itself, right? So why do we have a problem? And especially, why do we have a problem with the environment? What's specific about the environment that requires doing something about it that is different from just saying, okay, the market will take care of it? Right, so what I want to show is two things, essentially, two messages in this lecture. The first is that the market economy is surprisingly effective at handling the allocation of resources. It's quite amazing that such a decentralized system can do pretty well in many respects. But the second message is that there are some issues, and in particular the environment is one of these fields, these domains where the market economy is not equipped to deal with the problem, and I will try to explain why. Okay, so let's focus first on the first point, which is the market economy is working pretty well. And so you are actually familiar with the market economy because we live in a market economy, so you are doing market transactions every day. But nevertheless, it's not so obvious to understand what's going on and why it works so well. And so I'd like to start with a little experiment so that you can get the intuition for why things are working. So I hope you can see, you have here the choice between three brands of bottles of water, and I'll be assuming, and I hope you'll buy this assumption, that you need a bottle of water, and so you want to buy one. The question is, which one do you want to buy? And there is something special happening here in this economy, which is that the price of a bottle increases with the quantity that is supplied, because the cost is increasing, so the marginal cost means the cost of the last unit which is produced, is increasing in the quantity supplied, right? So the more a brand is being sold on the market, the more expensive it is. That's what's going on in this market. And the question is, each one of you needs to buy a bottle of water. Which brand do you choose? And so what I ask you to do is to take your clickers, and before you click on anything, I'll show you what will happen, right? So here you have three brands. And the three brands, so you can click on A, B, or C, meaning that you choose to buy from this brand. And you will see, in fact, the numbers, the bars that will appear, which represent how many of you are buying this brand, will also reflect the prices on the market, because the more of you buy a particular brand, the more expensive it is, right? So if you see a bar, it represents the price. So if you want to buy cheaper, you go to a brand that has a lower bar. That's the idea, okay? Is that clear, or is there anything unclear about the setting before we start the game? Is there any question about how things are going on? Yes? Yeah, so you are not forced to just buy one and commit to it. You can change your mind. If you see it's more expensive, you can change your mind. That's the whole goal of the thing, right? Okay, so you can click on one, change your mind, you buy another. And at some point, we'll stop. Okay, it's a bit like an auction. Yeah? Any other question? No? Okay, so I think we are ready to go. Let me open the market. Okay, so, let's stop here. That's not bad. Could be better, frankly, between you and me. It could be a bit better. But you see, sometimes it takes, I've done that with other classes, sometimes it just takes 2 seconds to reach full equality of prices. So you see, it's in the interest of everyone to buy the cheapest, and everyone doing that, we end up with a situation where the price is about the same for all and the quantities are about the same. So I don't know what you will get if you go there. Sorry for those of you who chose that. It may not be so, so good in terms of quality of water. Okay, so, sorry?
No plastic.
No what?
No plastic water bottle.
Oh, no plastic. Okay, sorry about the plastic. Yeah, I didn't think of that. Okay, yeah. So next time I'll put cardboard bottles. Okay. All right. So let's try to understand what's going on here. So what did we achieve? So what we achieved here is that we had a situation in which everyone, in principle, except for those who went to C and D, got a bottle of water. So we have an equality between supply and demand, right? That's the kind of standard market equilibrium thing. But there is something more interesting about what happened. The fact that we end up with equal quantities, or almost equal quantities and equal prices, means that the total cost of production of water in this economy has been minimized, right? Because if a price is higher for one brand than for the other, it means that the last bottle produced was more expensive to produce in this brand. And so if we reshuffle, if we switch production from this brand to the other, we reduce the cost for this one, and the other is cheaper to produce, so that reduces the total cost. And so not only have we achieved a situation where everyone has got a bottle of water, but on top of that, we've achieved something about efficiency, which is that we minimize the total cost of production, right? So this is pretty nice because this game is quite decentralized. Everyone is on his own. And so if we had wanted to do it in a centralized way, we would have to reason, so we need to share equally the quantity of water among the 3 brands, so we need to allocate that. So how to draw randomly across people and all that. So that is something that would have been a bit cumbersome. And we've done it in a few seconds in a totally decentralized way. Now, there was a hidden assumption. So forget the plastic issue. There was another hidden assumption here that I made in this game, which is that each one of you was able to afford the bottle of water. And that is not necessarily true in the real world, right? And so we've seen something pretty good as far as efficiency is concerned, but equity may not be guaranteed in the market. So I'll come back to that. But that's something that we already see in this example. And so how is it possible that a decentralized mechanism like the market mechanism is able to achieve such a feat of achieving some kind of efficient allocation? In fact, the trick is not such a trick. It's not a magic trick. The price mechanism is actually a sort of centralized coordination mechanism. Everyone sees the price tags, right? You had that on the screen. And that was an information that was public. And this public information was the coordination device that helped you reach this equilibrium, right? And so it was key here that everyone could see the prices. And before we started, we had a problem with the projector. That would have ruined my experiment because you wouldn't have seen the prices, right? Okay. Now, let me dig a little more into what economists mean by efficiency, because it is something that's often surprising for non-economists, and it's not what people usually think of when they think of efficiency in economics. So the core notion of efficiency in economics is called after Pareto efficiency. Pareto is an Italian scholar who was a pretty questionable character, but nevertheless he is famous for this notion of efficiency. And Pareto efficiency is the idea that when you have achieved this efficiency, it is impossible to make some person better off in the economy without making someone else worse off, right? So roughly speaking, the idea is there is no waste in well-being opportunities in the economy, right? You cannot improve things for everybody at the same time. Impossible, right? And so the key thing, the thing that's surprising about this, for those who have some views about economics which are not too positive, is that this is only about people, right? So it's not about moral persons like corporations or government. It's only about individuals, human people. And so economics, when it talks about efficiency, is only interested in the well-being of people, real people, flesh and blood. Okay, so that's something that is important to know. And so let me now, so you've seen how the mechanism can work in practice, but why does it work? Can we understand a bit better how the mechanism works? So let me think of two goods that have the same price. And we have this example with the bottles of water. But let's imagine it can be different goods. And let's imagine that a unit for each has the same price tag. When we are at the equilibrium allocation, there is something special, which is that no private agent, no individual, wants to give up 1 unit of one good for less than 1 unit of the other good. Why that? Well, because the market gives the opportunity to have 1 for 1. So you wouldn't accept to trade for something that's less advantageous than that, right? And so this is, what is remarkable about that is that this is true about everyone. Everyone, the coordination is through the fact that no one in the economy is willing to give up 1 for less than 1. And so that is triggering a situation where it's impossible to reallocate the two goods across people in a way that's beneficial for everyone. Because if it's beneficial for someone, it means that he has an advantageous bargain. He gets more than 1 for 1 unit. And if that's the case for one, it has to be a disadvantageous bargain for someone else. And then we are in a situation where we have losers, and so we have been unable to improve the situation for everybody. And so the allocation is efficient. Okay? Do you get that? Is there any question? Okay? So you see the prices that everybody faces, and everybody faces the same prices. The prices coordinate people's willingness to trade off one good for another. And this coordination is producing the efficiency. And so my example, in order to have simple sentences in my presentation, I assume they had the same price, these two goods. If they have different prices, if one is twice cheaper than the other, then 1 unit of one gives 2 units of the other, but the reasoning is the same, because all the people will coordinate on the same trade-off. And that's true of individuals, households. It's also true of firms. And that's important because the choice of technologies by firms is also a matter of trading off goods for goods, inputs for inputs, and inputs for outputs. And so all the private agents coordinate with the same prices. And so I said that the firms don't matter as such because we only care when it's about efficiency, we only care about real people. We don't care about firms. But firms, their decisions matter because they have consequences for the stakeholders. And the stakeholders in a typical capitalist economy are the shareholders, right? Those who will receive the dividends, the profits for the firm. So the firms act on behalf of their shareholders, and that's something that matters as well. You'll tell me there are other stakeholders in firms. Of course, you have workers and all that. But if we assume that we have a perfect market equilibrium, the workers have their wage guaranteed by the equilibrium wage on the market. And so somehow they are less directly affected by firms' decisions than shareholders whose dividends depend on the profit. Okay, is there any question or comment on that? No? Everybody on board? Yeah? Okay, great. So the efficiency result that we have is something that has been quite influential in economic thinking, starting with Adam Smith. I mean, Adam Smith didn't really understand all of that in detail, but he envisioned the idea all the way through the 20th century economists. But nevertheless, quite early in the 20th century, people started to realize that the efficiency of the market was not guaranteed because there may be some problems in real life. And so what kind of problems? The first problem, and so all these problems correspond to assumptions that need to be satisfied to guarantee that we achieve efficiency in a market economy. So if these assumptions are not satisfied, we have a problem. And so one key issue is market power. If the agents don't take the prices as given to them, if they know that they can manipulate the prices because they are big enough in the market and they can do it at their advantage and at the expense of the others, then the reasoning I was giving about everybody coordinating around the prices no longer works, because those who can manipulate the prices, they can think of the trade-off in a different way. And so so monopoly power is bad for the efficiency of the market. And typically what happens with a monopoly is that the monopoly is shrinking the market in order to raise the price. So think of a producer, a firm, shrinking the production to raise the price, increase the profit, but that reduces the benefit to the customers. Okay, so market power is an important thing. Another key assumption is full information. So we need to have commodities and services which are fully specified so that people don't have any uncertainty about what they are buying or what they are selling. They know exactly what they are dealing with. Okay? And so if we don't have full information, what happens? Well, especially if one side of the market doesn't have full information, then they will not trust the other side. They will be afraid that what they are buying is not exactly what is on the box, for instance, on the package or something like that, right? They will be afraid of the quality. And there are many cases in which this is the case, in which information is imperfect. And so when you have imperfect information, lack of trust, what happens? Well, what happens is that the market transactions, you have less of them than you could if you had full information. Because of this lack of trust, there are some opportunities for trade that will not be realized because of distrust, and this is a source of inefficiency, right? So typical example of lack of trust is on the labor market. When people hire workers, they are not sure what kind of worker they are hiring, and so that's one hurdle. Another example is on the credit market. When you lend money to someone, you are not quite sure of how hard this person will try to reimburse you. So the risk of default is something that you are not quite sure about. Lack of trust again, and so on and so forth. In insurance market, if you insure someone, you are not sure that he will be careful about maintaining the property that is insured. Again, okay? So all of this destroys some opportunities for trade. Another assumption that is important is that you need to have complete markets, which means that all the influence and all the interactions across people need to be contractible. You can have contracts, you can have transactions about them. And I'll say more about that because this is really the key thing about the environment. We have a problem of markets with the environment. We have a problem of influences across people which are not contractible, and this is something that is important. And finally, something that's obvious, let me go over it quickly. It's important that people are not excluded from the markets, right? So we need to have equal access for all people to all the markets. Okay? Questions or comments? No? Yeah? Okay. Right. And so that's about efficiency, okay? So you need to have all these assumptions to get efficiency in the market economy. And so this is very demanding. But even if all of that is satisfied, even if you have an efficient market economy, that doesn't mean that the situation is socially optimal, right? And so the market economy is not designed to reduce inequalities. Well, there is something, and actually Adam Smith is the one who noted that early on. There is something about the market that somehow reduces some inequalities. If you have poor people and rich people, the rich people can hire the poor people, paying their labor, and that is a way of reducing the inequality in consumption or in income, right? So somehow there is a mechanism there that reduces inequality in consumption. But it doesn't reduce inequality in wealth if you include in wealth the human capital of people, right? So essentially what happens with the market is people come with endowments, including their human endowment, and they get the value of this endowment on the market. They can spend that, and that's it, right? So if you have more endowment, you have greater wealth, and you are better off, and that's it. So the market is not reducing automatically the inequalities in endowments, and actually under some imperfect conditions it can increase the inequalities. And the typical example is this problem of trust in the credit market. When you are rich, you can bring collaterals, and so it's easier for the rich people to get loans than for poor people, and that is something that can increase inequalities across people, right? So you have, even in the news, you hear about some people inflating their wealth in order to get access to good loans. I won't give particular names. Let me now go to the question of the environment. So what is really wrong about the environment that the market economy is not able to handle? So if you don't mind, I'll do a little experiment again to give you the intuition of what's going on that is different from the market environment. So this is a different game in the sense that instead of showing you the result right away, I will ask you to use your clicker first, and if possible secretly, don't coordinate with your neighbors. You are each on your own, be discreet, and we'll see the results afterwards, okay? So that's a different kind of game. And so the game is quite simple, actually. So you can click on A or B, so no C or D and so on, please. You will get X dollars. So this is just hypothetical. I'm sorry, I didn't bring a lot of money with me. But let's assume you get X dollars, where X is the number of students in the room that clicked on A, okay? If you click on B, you get the same plus a bonus. You get a bonus of $10, right? Is that clear? Is there any ambiguity about what's going on here? No? Okay, so let's try to see what we get. Let me open the game, and you do one click, and that's it, okay? All right. Wow, you are that many? Whew. Okay. Okay, good. So that's enough, I think. All right. Let's see the results. Okay. So, what are the payoffs? So those who clicked on A will have $83. Those who clicked on B will have $93. Okay? We had 136 people in the room. So if everybody had clicked on A, everybody would have got 136. So everybody is worse off than that. Okay, so what's going on here, right? Is it okay? Can I hide that now? So let's analyze the game. So we have N students in the room, 136. If everyone clicks A, everyone gets N. If there are D defectors who go to B, everyone gets N minus D. And sorry, this is a bit misleading. I realized this morning. It's N minus D without the bonus. Okay, that's the basic thing you get. And so all those who click A suffer as the result of the defection. And those who click B, they may suffer if the bonus of 10 that they get is not enough to compensate for the loss, right? So if this is, and so when does that happen? Well, when the number of defectors is greater than the size of the bonus, which was 10 in my example. Okay, so we had in this room 53 defectors. That's much more than 10, and so we have something that is a typical prisoner's dilemma. So the expression prisoner's dilemma is due to Albert Tucker, who was actually a professor here a long time ago. And what happens in the prisoner's dilemma is that individual interest, which is indeed, if you just think of yourself, doing B is more rational because you get the bonus. If you don't do B, you don't get the bonus. Individual interest undermines individual interest indirectly because what's in your individual interest is that the others do A, because that increases the basic payment. But the others do A. If that's not in their individual interest, that is undermined by the situation. Okay, so we have what we call a collective action problem. Is that okay? Is that clear, or is there any ambiguity or any question? Yeah? So you are increasing, yes, that's right. You are increasing, you get the bonus and the others don't get the bonus. That's right.
$1, right?
Sorry?
You're only suffering $1.
That's right. So it's absolutely. So the question, if you didn't hear, is if you click A and then you switch to B, you are losing $1 in the basic payment because you are no longer contributing to the basic payment, but you are getting $10, so you get $9 as a benefit. That's true. That's exactly the point of the game. So individually, it is rational to, it is in the interest of everyone individually to do B, provided that the others don't change their strategy, right? So if you take the strategies of the others as given, it is in your private interest to do B. Is that, yeah? Okay, good. Is there any other thing? Right? So it is always in your individual interest to do B, but you may end up in a bad result because of that. That's the point of this situation. So if you explain that to people, sometimes they change their behavior. So do you want to try again? If you were to play that game again, what would happen? Okay, so let's do it quickly. We don't have that much time. So let me start. Three more. Thanks. Okay. Aha. Okay. So we still have 40. Yeah, so it has had some influence, you see? So it's not as if it had no impact. Is it sufficient as an impact? Not sure, right? So persuasion by itself may work, but may not be sufficient to completely solve the problem. Okay. So what should we do then? There is another way of thinking about it. We can use public authorities, right? So we can vote. If we vote, right? So now you can still choose an option, but this option will be imposed. It will create a system that will be imposed on everyone, right? And this is a sort of central coordination that was missing in the game, in the initial game, because each on your own, it was in your private interest. Now, what's in your private interest when you vote for an option that will be imposed to everyone? That's a different question. Right. And so political coordination is a way of addressing the problem. And so we can vote if you don't mind. Let's try what you would prefer. So here are three options. A now becomes, it's a prohibition. B is prohibited. And if you click on B, 5 years of imprisonment. Okay? Don't worry, there is no policeman here. If you, now the B option, sorry, I'm using A, B, C because it's what you have on your clickers, right? So B means that you get a fine, and the fine is just a part of the bonus, so you still get a bonus, but a smaller bonus of 3, and so your interest, your private interest is quite reduced to $2 if you switch from A to B when you play the game. And finally, the option C is that the fine is really quite severe. After the fine, you get a negative bonus if you go for B. Okay? Do you have a preference about these options? Let me open the vote. Now it's a vote. Three more or not? You can abstain. That's fine. Okay, good. So, what do we have? Aha. Yeah, I was kind of expecting that, right? So pure prohibition sounds a bit severe. The superfine is pretty efficient because now it becomes your private interest to comply, right, with the public interest. Whereas option B is may work, may not work fully. So there is an issue of calibrating the incentives. So the goal of this kind of policy of having a fine is to make people internalize the consequences of their actions on the others, right? So the internalization process requires that you have a fine that is sufficient so that the private interest is really aligned with the public interest. Okay, so you've got the point. And so let me now, in the remaining time we have, explain a little bit more in detail what kind of problem we have with the environment, because actually these problems come in several flavors. So in all of these problems, we have a kind of prisoner's dilemma, at least in the first three. We have a kind of prisoner's dilemma, but it's coming through different ways, different channels, and this is what I'd like to explain very simply. So the first thing is externalities. Okay, and externalities, the typical example is pollution. So what is an externality? An externality that's really, it has a technical meaning that is very precise. It's a trade or a private action that can influence third parties which are not part of the transaction, right? So these third parties, there is no transaction with them, okay? And so examples of externalities imposed on households, for instance, you can have something that's positive or negative. So for instance, hearing music may be positive if you like the music. If you hear noise, then it becomes a negative externality that you receive. Firms also can receive externalities. Some of these externalities are positive. So the typical textbook example is beehives and orchards. So if you have an orchard plot somewhere and beehives nearby, the pollination done by the bees is helping. So the guy who is running the bee industry is helping the guy who is producing fruit. Okay, so. But there are other examples which are a bit more tricky, but which have to do with the agglomeration of activities in places. So usually you benefit if you are in a hub of economic activities, you are not isolated, and you can benefit from various externalities through the fact that labor force is easier to reach, and so on. And infrastructure will be concentrated around you and so on. So moving to a place will actually influence other firms which are nearby and this sort of thing. But you also have negative externalities, and an important example of a negative externalities between firms is advertising. Of course, I don't know about you, personally I don't like advertising, so I think it's a bad externality for me. But also between firms, because firms, it's a sort of arms race between firms. You need to advertise at least as much as the competitors in order to be seen on the market. And so they are spending too much, actually, on advertising, even if it were just about their interest, which is to reach more customers. Right? Now, what do we have with the environment? So the typical example of an externality is pollution. Right. And here we have a structure of prisoner's dilemma, because we could reduce the pollution if everyone made an effort to abate, but and it would be great if everyone abated, but the best situation for most private agents is when everyone else is abating, so the environment is clean, and this private agent, isolated, doesn't make any effort. Right, doesn't make any effort of abating. And so that's what we have. So when you analyze, let me explain how you read a game like that, if you have not seen this kind of matrix. So you have two players. You have this guy here who is the column player. He can pollute or abate. And you have the row player who can pollute or abate. And these payoffs here are the payoffs of the two players. The first one is the payoff of the row player, and the second one is the payoff of the column player. Right? And so they want to have higher payoffs. And so if they both pollute, their payoff is 1-1. If they both abate, their payoff is better. But if, suppose the row player is polluting, what should the other player do? Well, the other player will compare 0 here with abating to 1. And so 0 that's a bad payoff for him, because he makes an effort, but the environment is not clean because there is pollution. And so it's very bad for him. It's very good for the polluter who is the single polluter, right? And so the column player will compare 0 to 1, and so it's better to do 1, and so both will pollute if they reason in this way. If the row player abates, what happens? Well, the column player will compare 2 if he abates as well, to 3 if he is the only one who doesn't abate, and 3 is better than 2. So the private interest, again, is for polluting. And the game is symmetrical here, so the row player will reason in the same way. And so we'll end up at an equilibrium of the game if they all reason in this way. This kind of equilibrium is called a Nash equilibrium, but it doesn't matter too much. But the equilibrium will be that they will all pollute in this case, which is not as good as they could do if they went for, so it's inefficient, right? It's Pareto inefficient. They could achieve something better for everyone if they did that. Okay? So the key point about externalities is that sometimes, very often, people, when they look at externalities, they think of the harm, right? Which is indeed a dimension, and in the section of the course where we talk about harm, you'll hear about that. So that's the dimension. But for economists, there is something else about externalities which is important. They are just producing inefficiencies. It's inefficient. We have a lack of transaction between these people. They don't come to an agreement. Each one on his own is making a decision that is focused on his own interest and ignores the impact on the others, and this is creating the inefficiency. Okay, so externalities, the key point about them is that they generate inefficiencies. The next thing I'd like to talk about is, unless there is a question, sorry, is there any question? No? Yeah? No? Next point, commons. So what are commons? So commons are, again, that's a technical term. Commons are durable resources that are left in open access and which will tend to suffer from overuse because of the prisoner's dilemma structure again. But the problem comes from the open access, right? So commons mean it's an open access resource, but it's an open access meaning that people will seize some of that, will use some of that, and so it's not as if everyone was benefiting from the fact that the resource is there. They benefit, but they will use it for their own purpose in a private way. So fishing is an example. You have a fish resource in the sea. If you go there and you fish, you are taking some of that, and that is no longer available to the others, right? The sea is open to every boat. You go there, you take some of the stock, and the others will have a lower productivity. So every fishing boat is reducing the productivity of the other fishing boats. And that's a sort of externality that is due to this open access situation. And so grazing in meadows and mountains and things like that by cattle and sheep and so on is the same kind of problem, right? So Garrett Hardin called that the tragedy of the commons. It's a tragedy in what sense? Well, again, what's tragic about that is not so much that one is harming the others or everyone is harming all the others. What's tragic is that it's inefficient. If everyone made an effort to reduce the use, that would be good because it would enhance the productivity of the others. And why would it be good? Because if everyone does that, also my productivity will increase. Right? And so there is, again, a situation where everyone should make an effort, and that would be good overall. So it's a prisoner's dilemma situation again. So Elinor Ostrom, who got the Nobel Prize for that, has studied small communities, especially fishing communities around lakes, where you see that people come up with mechanisms to check on the others and punish the defectors and so on. So a little bit like the political coordination mechanism we've been thinking about. They organize that in a rather semi-formal way, but they set up some rules and it works. And they know they can observe one another and so on, so it can work. But she has a paper where she says, what about global commons? So global commons like the atmosphere, like the quality of the marine life and quality of the ocean water and so on. What about these global commons? Then it's much harder, right? It's much harder because you have many more players, you have difficulty to observe what everyone does and so on. So global commons are much more challenging. And so what she advocates for global commons is something like what she calls a polycentric mechanism. So using all the levels of decision-making that you can. So some local decision-making can be relevant, some global decision-making can be relevant. All these can contribute, and there should be a sort of articulation between all these levels of decision-making, right? So polycentric mechanisms where you have incentives at different levels can play a role, right? So shaming your professor who shows plastic bottles can play a role. Shaming your neighbor who is using plastic bottles can play a role and so on. So all these can play a role, but at some point we need also global coordination. That is something that is that cannot be skipped, and it's hard to combine, of course, right? Okay, so this is about commons. Again, question, comments, or yeah? So you see, externalities, that's a pretty generic term. Influences, all sorts of influences that are not contractible. There is no transaction, no market for that. We'll come back to that in more detail. So in the next lecture, we'll talk about how to deal with these things, what are the instruments, and so we'll come back exactly to how it can work. So commons is special. It's the open access where people can grab things and ignore the harm they do on the others when they do that. And public goods, it's another category. Public good, so what is a public good? In economics, a public good is not a good that is produced by the public sector. That's not the idea. It's not that, right? It is something that is very specific. It's a good that is non-rival. And when I say a good, it can be actually a bad, right? Some public goods are not liked by people. But what's important is this non-rivalry property. And non-rival means that it can be simultaneously consumed or used by several agents, right? So you have several people can use it at the same time. And so that's the key characteristic. Then you have another characteristic that is orthogonal to rivalry, which is whether we can exclude people from the good or not. In some cases, you can exclude people. In others, you cannot. And so you have this table which shows all the categories of goods depending on how excludable they are and how rival they are. So this is a matter of degree to some extent because it is costly to exclude people, so it may be more or less costly depending on the goods. And rivalry, similarly, it's a matter of degree because some goods have congestion problems very quickly and others not so quickly. So all that is a matter of degree. So if you go to a pure public good is something that's totally non-rival and not excludable. So for instance, the ozone thinning, the thinning of the ozone layer in part of the atmosphere, that's so-called ozone hole, that's something that is really, it's hard to exclude people from benefiting from the restoration of the ozone hole. And it's typically non-rival, it's the same for everybody, right? Now you can have something that is totally non-rival or almost totally non-rival, but totally quite excludable in a cheap way. And that's, for instance, an online video where you can put a password on the video, right? And so only the people who have the password can access the video. That's a way of excluding those who you want to exclude, okay? So why do we want to exclude people? Well, you see, when you can exclude people, that can be good because it may be a way to force them to pay access to the good, right? So if you can say there is an entry fee, an entry ticket, then you can make people pay. And so there are many public goods which are excludable. So theaters, movie theaters, and so on, all these things provide public goods which are excludable. So courses at Princeton, that's a sort of excludable public good, even though we try to be open to the community. But if you want to get the diploma, it's a bit harder. And so this is a kind of thing where you have public goods, but with some exclusion. And why do we have that? Well, because the producers then can get rewarded for providing this public good. Otherwise, you wouldn't have many theaters and all that if there was no payment for that. On the other extreme, you have a good that's totally rival and excludable, typically is something like food. Once you have eaten a piece of food, it's very hard for someone else to consume it as well. And so that's a key example of something that's rival and excludable. Actually, a good that is totally rival is typically excludable, right? Because just by consuming it, you are excluding the others from consumption. So there is some sort of logic impossibility in having something that's rival and not excludable. And then you have things which are in between, okay? So a course at Princeton has some congestion. A city street can have some congestion and so on. And it's very hard to exclude people from a city street and so on. Okay, and so the problem with public goods is, again, a problem of inefficiency because the non-rivalry, if it is accompanied by non-excludability, means that the producers cannot be rewarded for providing the public good, and therefore there will be underproduction of the public good. And you have the opposite, of course, for the public bads. You cannot really express your dislike of the thing, and so you will not be able to punish those who provide the public bans in the way you would like. Okay, so that's about public goods. And finally, the last item we need to look at is exhaustible resources. Exhaustible resources are things which are actually typically not in ideal situations, a problem for the market economy. The market economy should be able to handle exhaustible resources well, but the problem is that the agents are not always rational. And so if you have, for instance, if you have a sequential arrival of users, which is the case when you have a sequence of generations, if the first generations are myopic or selfish, they may overuse this resource and not leave enough for their descendants, right? And so that's a real issue. It's not a failure of the market per se; it's a failure of the agents when they are either myopic or selfish. Now, we don't have much time, but let me look at the question here. If we look at climate, to what category of problem does it belong? And what's remarkable about climate is that it belongs to all these categories at the same time. Okay, so it is an externality problem because everyone's emissions affect other people, right? So when you use your car and so on, you affect other people. It is a commons problem because when you put CO2 into the atmosphere, you are essentially using this open access thing, which is the atmosphere. And so it's a commons problem. It's a public good problem because having a good climate is a public good for everyone. We benefit in many ways. And it is also, we can also frame it as an exhaustible resources problem because the fact that the CO2 stays very long in the atmosphere means that it's as if we had a finite size of the atmosphere in which we can dump CO2. And so if we put too much at some period in history, it takes millennia before it disappears and others can use it again. And so the atmosphere has been filled by earlier generations, and now not enough is remaining. So again, it's a sort of exhaustible resources. So the climate is somehow combining all of these things at the same time. If you look at the IPCC report, the last one, they mention this as a collective action problem. They insist on the fact that it is a global commons problem, right? But it is all these problems at the same time. Okay. If we look at the environmental nexus, we can look at all the things as they are. So as I said, in the climate, you have the atmosphere as a global commons, the climate as a public good, and the emissions as externalities. I'd like to add one more dimension. I talked about the inequalities that are not addressed by the market economy. And so we have inequalities also in the environmental nexus. So we have unequal vulnerability of different populations to climate change. And that is something that should always be in our mind as well. When we look at water, also we find similar problems. So we have the precipitation regime, which corresponds to a sort of public good, right? Especially for the people who depend on that for their production system, like food production. We have the aquifers, which correspond to commons, and when we take from them, you remove for the other users. The pollution of water is essentially a public bad because when the water is low quality, it's bad for everyone. And as you'll hear in this course, the water problem is a lot about inequalities, the distribution of water across regions which have different situations. So it's a lot about inequalities. When you look at food, food depends a lot on the quality of the environment. So food production, productivity depends on the climate and the quality of the soil. And so we have one aspect here. But food production itself is a generator of externalities through pollution, through various things. But yeah, pollution is a key aspect. And of course, a key issue for food is inequalities again. Biodiversity is a bit more tricky if you want to apply our categories to biodiversity. So obviously the ecosystem is a public good, so we can treat the diversity of species as a public good. We can think that there is something more than that there is an intrinsic value of nature, and that is not in the categories I've been introducing before, because I was always referring to efficiency as economists define it, which is always in terms of human beings, the well-being of human beings. So that was very anthropocentric. So if we want to get out of the anthropocentric framework, we need to get out of the usual economic thinking, right? So I'm not saying that economics is not able to go out of the anthropocentric way of thinking, but it's, some work remains to be done. We could actually introduce the other species in the analysis, and that would be interesting. And we could see our activities as imposing externalities on the others. And finally, inequalities between species is something important. Now, last slide. There is market failure. There is also government failure. Right. So these examples comes from Europe. We'll come back to it. It's the trading system, the emissions trading system in Europe, where the price has remained desperately low for a long time because of mismanagement of the system. So bad public policies can really also screw up the system. And so we should never forget that the market economy is imperfect, but government is also very imperfect. That's enough for today. Thank you.